All right, the last of your notes for today is this slide on box plot, and you need to copy everything. You need to copy the definition for box plot, and I also need you to draw this little picture and label each of the points. I know you are going to think, oh my gosh, this is a lot now, but this is going to be super helpful to you when you start on the digits assignments, because you need to know what each of these points on the box plot represents. Okay, so as you're copying this down, I'm going to explain what a box plot is. It is a statistical graph that shows the distribution of a data set by marking 5 boundary points where data occur along a number line. Unlike a dot plot or a histogram, a box plot does not show frequency. It is just showing you the spread of the data. The first point on a box plot is called the minimum. This is the smallest number in your data set. On the other end, the last point from your box plot is called the maximum. This is the biggest number in your data set. If you were given a box plot and asked to find the range, what you would do is look at the box plot and see what is the maximum, which is right here. It's 7.5 for this box plot. What is the minimum? It's right here. It's -3. And then you would use your little range formula, biggest minus smallest, to find the range. Okay? So that's one type of problem you would need to solve from a box plot. Other parts that you need to know from a box plot include the box. The first quartile is Q1, is the point that is the left side of the box. There's going to be a line in the middle of the box, that is the median. And then the right side of the box is Q3. So another question you might be asked is to find the interquartile range, the IQR. Remember the formula for the interquartile range is Q3 minus Q1. So you would have to find Q3, which in this case is 5, Q1, which in this case is 0, and then you would subtract 5 minus 0 to get that the interquartile range is 5. So you need to know what each of these points means, what they stand for, so you need to make sure you have this labeled. I'm telling you this now, copy it down. If you don't, you're going to have a very hard time later, and I'm going to tell you to come back to the video and copy it again, so you might as well copy it now, okay? All right, let's look at just a couple of questions that you might have to answer from a box plot. They're asking you to find the range and the interquartile range. Again, the range is biggest minus smallest, so from my box plot, this looks like it's at about 201. That is my maximum, my biggest value. This right here looks like it's about 144. Okay, that's my minimum. So I would find the range by subtracting the biggest minus the smallest, 201 minus 144, and that would give me 57. So the range would be 57. To find the interquartile range, remember I do Q3 minus Q1. Q3 is the right side of the box plot. Q1 is the left side of the box plot. So I just read the numbers. This looks like it's about 188. This looks like it's about 155. So I would do, for the interquartile range, I would do 188 minus 155, which is 33. So my interquartile range would be 33. Okay? Again, the range is coming from the biggest and the smallest. The interquartile range is Q3 minus Q1. And then it says describe the variability. So you would look at how spread out are the numbers for the temperatures at this hot spring. Since the lowest number is 144 and the highest is 201, that is a range of 57 degrees. That is a pretty high range. Thinking about a pool would change temperature, 57 degrees, getting either warmer or cooler, that is a pretty big range. Okay. Last thing, how can you use measures of variability to compare data? Copy this into your notes. You can compare two data sets by comparing their individual data values. A quicker way to make a general comparison is to compare their measures of variability. So again, measures of variability include the range, the quartiles, the interquartile range. So you would just look at the spread of the data. Like here we have a class, we have a range of 3. Here we have a class, we have a range of 5. So you would say that class M's data is closer together than class R. Okay, and they may give you a couple questions like that on digits to compare two different data sets. So let's try this one. We have two different box plots. They're asking us to find the interquartile range of hours slept, making a comparative inference. So first let's find the interquartile range. Remember that is going to be Q3 minus Q1. So this looks like it is 7.2. This one is at 5. So I would do 7.2 minus 5 is 2.2 is the interquartile range of hours slept for the cell phone group. And then for this box plot, we're going to do Q3, which is 8, minus Q1 is about 6.8. So we would do 8 minus 6.8, that is 1.2 is the interquartile range. So comparing the two groups, which has the bigger kind of spread of data? Which interquartile range is bigger? This one. So we would say that the no cell phone group is more consistent. That means that they're closer together because the interquartile range is smaller. The cell phone group is not as consistent in how many hours of sleep they got because the interquartile range is bigger. Okay, at this point you should be ready to try digits 15.3. Keep these notes handy. They will be helpful to you in answering the questions. If you need help, raise your hand.